U-Substitution is a technique that can be used to find indefinite and definite integrals. Let's look at it first for just indefinite integrals. It says if we want to integrate something in this special form, f of g of x times g prime of x dx, we can make this substitution u equals g of x and turn that indefinite integral into this indefinite integral. The goal here is to make a new indefinite integral that's easier to compute. You might recognize this as the result of the chain rule, and that's in fact the case. U-Substitution is a way to recognize how to undo the chain rule when creating an antiderivative. Let's look at an example. Suppose we wanted to integrate x cubed plus 3x all raised to the fourth power times 2x plus 3 dx. In this case, g of x will be x squared plus 3x. And that works really well because the derivative of x squared plus 3x is 2x plus 3, and that also appears in the equation. So let's try to make the substitution u equals g of x. So if we let u equal x squared plus 3x, in order to complete this, we have to figure out what du is. So this is where we use the differentials we talked about before. Du, to find du, we take the derivative of x squared plus 3x, which is 2x plus 3, and we multiply that by dx. Remember, we need balanced differentials. If we have du on this side, we need a dx on this side. In this case, 2x plus 3 times dx appears directly in the integral. So we can replace the 2x plus 3 dx by du, and we can replace the x squared plus 3x by u. And what we're left with is the integral of u to the fourth du. That's the substitution. We put in u for x squared plus 3x. We put in du for 2x plus 3 dx. Now this is a new integral that's in terms of u. It's just an indefinite integral, and we find the antiderivative of u to the fourth du. That's very easy to do. It's u to the fifth over 5 plus a constant. So we've started with this integral, turned it into this integral. That was a much easier integral to do. That was the goal of the u-substitution. And so now we've found the integral. But we're not done yet because this answer is in terms of u, and we need this answer in terms of x. So in for u, we have to put back in x squared plus 3x. So in for u, we substitute back in x squared plus 3x. And we end up with x squared plus 3x to the fifth over 5, all plus a constant. That's the answer for this indefinite integral. Let's look at another one, a little bit trickier. Here we have the integral of x times x squared plus 3 to the fifth times dx. Well, it looks like a similar thing might work, so we might try u equals x squared plus 3. From this u, we compute du, and so when we compute du, we take the derivative. So du is 2x times dx. Now we don't have a 2x times dx here, but we do have an x times dx. So that suggests that in for x times dx, we substitute, and if we want to do that, we would solve this for x dx. So that is, we would divide both sides of this expression by 2 and say du over 2 is equal to x dx. And so then, in for x squared plus 3, we can put u. In for that x times dx, the dx and the x together, is this x dx, and we can put du over 2. And we can end up with this integral. It's very important when you do these substitutions that after you're done with the substitution, this is totally in terms of u, and there's no x's left. If that didn't work out, then you haven't done it right, or you've picked the wrong substitution. In this case, we were able to do it because the x and the dx appeared. The 2 was just a constant, and we could resolve that by using du over 2. So now we just have a simpler integral to do. We just have to integrate u to the fifth. The 1/2 can come out in front, so it's 1/2 times the integral of u to the fifth du. The integral of u to the fifth is u to the 6 over 6. We add on an arbitrary constant. So we've been able to pull off the integral. We changed a complicated one into a simple one. Now to get the final answer, we just put back in the x squared plus 3. So 1/2, 2 times 6 is a 12th, and for u we put x squared plus 3, all raised to the 6, plus a constant. That is our new indefinite, that's the indefinite integral. That's the answer for this problem. So u-substitution is a powerful technique. It takes some experience and some practice to figure out the right substitution. And you have to make sure when you use that substitution that it works out. That is, that du is going to be something that absorbs up all the x's and the dx's, so you're left with something totally in terms of u. It doesn't always work, but when it does, it's a very powerful technique for finding indefinite integrals.